Radioactive substances that emit gamma rays, like technetium, can be injected into the body to produce images. This machine has a gamma camera. It detects the gamma rays emitted by the technetium. 15-year-old Daniel was born with a hole in the heart. He's been coming to Guy's Hospital in London since he was 2. Today, he's here for a technetium injection. Radioactive technetium is pretty dangerous stuff, but a small measured amount of it can detect a life-threatening medical condition. For Daniel, radioactive imaging is the best way to make sure his heart is functioning correctly. But first, Daniel's technetium injection has to be made up in the hot lab. Safety clothes and radiation monitors have to be worn to protect the staff.
This is where the radioactive technetium is produced, and this is what we're going to use to make up Daniel's kit for this afternoon. I'm going to use a syringe and needle to draw up the radioactive technetium, but to protect myself from the gamma rays, I'm going to insert it inside a lead syringe shield, and at the front you can see there is lead glass so that I can see through into the syringe what I'm actually drawing up. The radioactive kit is now ready to be taken out and used to inject Daniel.
The technetium is taken to the preparation room, where the exact dose is carefully measured. The dose is small enough to create a good image of Daniel's heart without putting him at too much risk from the dangerous effects of radiation.
I now have my dose. I'll take it to the camera in this protected lead box. Daniel.
We're just going to get you ready for the scan now, Daniel. If you turn your head round that way, I'm going to move the camera down. It's going to be very close to your chest, all right? But it won't move once it's in the right position. Okay? In a minute, Penny's going to give you the injection, and you've got to keep still for about 5 minutes. Okay? The camera's going to be detecting the gamma rays so that we can take pictures of your heart.
As the technetium is injected into Daniel's arm, we can see it being taken up by the bloodstream, which will finally make its way to his heart. Radioactive imaging has many advantages over X-rays. A standard X-ray only produces a static image, but radioactive images enable scientists to see body functions such as blood flow and even bone growth. Here we can see gamma images of 2 kidneys. They have revealed that one kidney is actually larger than the other. There are other types of radioactive substances used in imaging, like radiofluorine. Again, a gamma camera is used to detect the gamma rays emitted by radiofluorine. Here we have an X-ray and a radioactive image of the same hand. On the left there's the standard X-ray, but it was the radioactive image that detected the non-cancerous growth. That's it today for Daniel. His heart has checked out fine, and was it an awful experience?
Didn't feel a thing.